Imagine proving you're over 21 without showing your ID, proving you have good credit without revealing your bank balance, proving you voted without exposing who you voted for. This isn't science fiction. This is zero-knowledge proofs, and Midnight is built on them. Let's start with a real-world analogy. You want to prove to a friend that you know the password to a computer, but you don't want to actually tell them the password. How would you do it? One way, they give you a message, you encrypt it using the password, and show them the result. They check it against what the encryption should look like. They now know you know the password, but they never learned the password itself. That's the basic idea of a zero-knowledge proof. I prove I know something without revealing what I know. I prove something is true without showing the evidence. Another example, proving you have a certain disease without revealing your medical records. A healthcare provider could issue a proof that says this person tested positive for condition X without attaching their name, age, or any other data. Just the fact of the positive test. This is powerful for privacy. You can verify claims without exposing the underlying data. You can maintain compliance, proving you meet requirements without surveillance. Midnight doesn't just use any zero-knowledge proofs. It uses ZK snarks, zero-knowledge, succinct, non-interactive arguments of knowledge. Let's break that down. Zero-knowledge, we've covered this. Prove without revealing. Succinct, the proofs are tiny. A proof that you computed something correctly might be just a few hundred bytes, regardless of how complex the computation was. This matters for blockchain. Small proofs mean fast verification and low fees. Non-interactive. Some zero-knowledge protocols require back-and-forth communication between prover and verifier. ZK snarks don't. I create the proof, I send it, you verify it. Done. One round. Arguments of knowledge. This is the cryptographic guarantee that I'm not faking it. If the proof verifies, I actually know what I claim to know. Midnight uses a Halo 2-derived system for its ZK snarks. This is cutting-edge cryptography. Halo 2 allows for recursive proofs, proofs that verify other proofs, which enables incredible scalability. Here's the actual workflow on the Midnight network. Step 1. A user has private data. Maybe it's their age. Maybe it's their account balance. Maybe it's their medical history. This data never leaves their control. Step 2. They run a computation locally on that private data. For example, checking if their age is greater than 21, or if their balance is greater than the transaction amount. The computation happens on their device, not on the blockchain. Step 3. They generate a zero-knowledge proof that the computation was done correctly. This proof says, I performed this calculation and got this result without revealing the inputs. Step 4. They submit the proof to the Midnight network. Validators, the nodes running the blockchain, verify the proof. They confirm the computation was correct without ever seeing the private data. Step 5. The transaction executes based on the verified proof. If the proof says balance sufficient, the transaction goes through. But the validators never learn the actual balance. This is revolutionary. For the first time, you can have blockchain verification without blockchain transparency. You get the security and decentralization of blockchain without the privacy sacrifice. Zero-knowledge proofs have 3 critical properties. Understanding these helps you evaluate whether a system actually delivers on its privacy promises. First, completeness. If the statement is true and both parties follow the protocol, the verifier will be convinced. An honest prover with a valid claim will always succeed. Second, soundness. If the statement is false, a dishonest prover cannot convince the verifier it's true, except with negligible probability. You can't fake a ZK proof. You can't claim to have funds you don't have. Third, zero knowledge. The verifier learns nothing beyond the fact that the statement is true. They don't learn the witness. They don't learn the private data. They only learn that the proof is valid. These 3 properties together create a system where privacy and verification coexist. You can prove without revealing, verify without surveilling. Here's why zero-knowledge proofs are the key to mainstream blockchain adoption. Institutions, banks, healthcare providers, governments, they need privacy. They can't expose sensitive data on a public blockchain, but they also need verification. They need to prove compliance, prove legitimacy, prove operations were executed correctly. Before zero-knowledge proofs, they had to choose privacy or verification. Private databases give privacy, but no blockchain verification. Public blockchains give verification, but no privacy. ZK proofs split the difference. You can have a private database, your sensitive data stays private, but you can generate proofs that get verified on a blockchain. Compliance without exposure. Verification without surveillance. This unlocks use cases that were previously impossible on blockchain. Private healthcare records with provenance tracking. Confidential financial transactions with audit trails. Anonymous voting with verifiable results. KYC compliance without data exposure. Every one of these was blocked by the privacy-transparency trade-off. ZK proofs remove that blocker. Not all zero-knowledge implementations are equal. Midnight has some specific advantages. First, it's built in from the ground up, not bolted on later. The entire architecture is designed around ZK proofs. This matters for efficiency and security. Second, compact. Midnight's programming language automatically generates ZK circuits. Developers don't need cryptography PhDs. They write TypeScript-like code, and the compiler handles the ZK magic. Third, Midnight uses recursive Z-proofs via Halo 2. This means you can have proofs that verify other proofs, enabling massive scalability. Fourth, the dual token system, Night and Dust, creates sustainable economics for ZK computation. Generating proofs is computationally expensive. Dust captures that cost in a way that doesn't price out users. Zero-knowledge proofs sound like magic, but they're real. They're here, and Midnight makes them usable at scale for the first time. If you understood this episode, you now understand the foundational technology behind the entire Midnight network. Everything else, the tokens, the applications, the roadmap, builds on this. Next up, Compact, the developer's secret weapon. How Midnight makes privacy programming accessible to millions of developers who already know TypeScript. You don't want to miss it. Subscribe, hit the bell, and let me know in the comments if ZK proofs clicked for you. What questions do you still have?